do a quick walk around the amphibious tractor here. Just got back from a nice little woods romp. Engine's still a little toasty. Everything is basically a Russian inspiration, undercarriage, chassis with my own little ideas here and there. All prefabricated plate steel, CNC plasma cut, put on a press brake. Really takes the fabrication time out of the equation on my end. It's a little bit more money to pay for the parts, but makes it simple. You don't have to dink around with square tube skeletons and then skinning with sheet steel. Not to mention, any guy in the bush could build one of these. You don't need a shop, because everything is just, etch lined, slot and tabbed. All you really need is an angle grinder and a welder. And of course, simple hand tools to bolt everything together, but for the most part, simple home tools that anyone could really use, especially nowadays with the import welders and stuff, which is what I use, just a cheap Chinese welder. But yep, 1/8 inch steel, sides, bottom, rear, 12 gauge steel on the top, and then 3/16 on the front, so it can take the trees, take tree bashing and stuff. Sectional design, so then that way if I ever wanted to add a fourth wheel, all you got to do is just add, from a design standpoint, it's pretty simple. You just add another plate, you bring the tail back a little bit more, add your wheel, and you're good to go. Everything is under 80 pounds, all the steel components, so there's nothing over 80 pounds here, and everything can fit up on a standard GMA 40x48 pallet from a profile standpoint. So all the steel parts you see here can easily fit up on 3 standard pallets. Like I was saying, a sectional modular design, kind of like a building a ship, You got a split body design here, which allows you to accommodate pretty much any axle you want to put in here from a powertrain standpoint. I just got a welded on bolt plate for the pintle whenever I get one for towing a trailer or something, and a little drawbar hook here to pull shit. Moving on to the front, more recovery points or tow hooks, whatever you want to call them. Another angle of the split seam design to accommodate whatever axle gauge you want to put on here. And really, the nice thing is about this kind of universal chassis setup is the only thing that changes is this plate right here, because this is what designates what axle tube diameter you're running. So for example, a Ford 9-inch versus a Ford 8.8, which is what I'm running, would be a different diameter, so this is the only part that would change. Same thing goes if you're running a GM axle or a Dana axle. I probably wouldn't recommend putting a Rockwell in here, a 2.5 ton truck axle. That's probably a little overkill, especially from a weight standpoint. Moving on to the undercarriage, typical steel ladder track system, self-cleaning track, Russian inspiration. I mean, this design goes back to the 1930s. Joseph Armand Bombardier, that Quebec mechanic, came up with this back in the 30s, ladder track. But it's a little bit different because it uses the Russian style of tube type track, which they've been running for 10 plus years, so it's tried and true there. Bolt together design. This is just rectangular tube steel that's been crimped on both ends for easier skid steering. And then also the tire guides are just round stock that's been bent in a U shape, and then integral welded onto the track cross member in a jig to get your right angle there. And then of course you got your backer washer plate, which are just CNC plasma cut. Nylox, 3/8 grade 2 hardware, nothing special there. This is a 3-axle carrier, and I'm running ST205 75 or 14 trailer tires. These are Wally World specials. They're about 30 bucks a piece, I was pretty surprised at how cheap they were and how well they're holding up so far. I probably got about 40 miles on the machine so far, and sidewalls aren't really taking much wear. I don't know if it's design or just the way these things are built, but they've been pretty good so far. Cheaper than used tires. This is the tandem axle walking beam. Unfortunately, I had to lock it out, so right now there's pretty much no suspension on this machine. So it's kind of a rough rider. The reason I locked it out was because when you're backing up on a hill and you got torque going through the driveline here, you'll actually pull this walking beam up, you'll slam it into this chassis, this upper chassis plate, and yeah, that's no good. So I had to lock it out there. And I think in the future, I would definitely opt for more of a torsion bar setup. That'd be pretty slick, individual suspension on each road wheel. But the problem is with that, it's hard to find a torsion bar suspension where you can get more than 3 inches of travel. Because in my opinion, 4 to 5 inches is what you would need on something like this. But yep, these wheels are then mounted up on Ford Ranger alloys and then 3/4 ton spindles and hubs from a trailer there. And then you got a rigid rear axle in the back. The idler and the sprocket, they both use a 15-inch steel wheel from Ford Explorer. And they're both rimmed with conveyor belt rubber that keeps snow and ice from sticking. And then also it keeps wear off the steel track, because the track is your most expensive component for the most part from an undercarriage standpoint. Moving on to the sprocket, this is one thing I would definitely change in the future. Because right now I tried to run a stock Ford Explorer wheel, 15-inch Ford Explorer wheel, just from simplicity standpoint. But the problem is the way with the offset. Let's see if you can see this or not. But because the offset's not great enough towards the inside, I'm having some track guide interference issues with the brake bleeder valve and then also the banjo bolt on the caliper. Because this is a brake differential steer unit, like on a Brun gun carrier. So, when you get a point load on the edge of your track here, it'll twist the track, and it'll pretty much slam one of these track guides as it's rotating into the bleeder valve, and then it dumps all my brake fluid everywhere, and I lose steering in one area, and it's just no good. So this would have to be a completely fabricated sprocket wheel in the future. But the nice thing about that is I can control my diameter this time, and I can make it a little bit smaller so that I can get more force output instead of speed. Because right now I'm actually running a dual caliper setup. It is still quite a bit of takes quite a bit of grunt work to get this thing to steer in vegetated swamp, that hard to brake terrain. Yep, that's definitely something I'd change in the future. Definitely make my own sprocket wheel there. But the sprocket teeth themselves are another Russian inspiration, pretty ingenious. It's just cast polyurethane sprocket teeth, and then they're bolted up onto the wheel itself, which makes it, like I said, keeps snow and ice from sticking and then wear off the track. Plus, it's also field replaceable teeth, which is pretty cool. And they're reversible, so especially you'll start wearing this edge more than this side, just because of the standpoint you're going to be going forward more than backwards. But yep, same thing goes on the other side. It's just a symmetrical chassis there. 2-link overlap splice, like on a Nodwell, other industrial track machines. And you can see here, I got my plug holes here. These are actually for track extensions. I have some 1x1 angle, and that'll add another 5.5-inch belt around the outside here to give me more flotation and grip during the winter. So it makes it more of an all-season machine than anything. Moving on to the back again. This is another Russian inspiration here. Idler tensioner design. 2 posts that the assembly slides on, and then you got your jack screws that pulls the track to tighten it up, and then you got your locking bolts right here. Good deal there, simple and reliable. That's what I like about the Russian designs. The interior is not really finished for the most part, but we'll move in here anyways just to kind of give you an idea of the powertrain. Definitely a lot of space, because I was kind of going for that universal chassis kind of deal. So, you can put a Cummins motor in here, whatever you want, V8, V6. Definitely a lot of ample space, real estate for bigger powertrain components. I'm running a Toyota 4-cylinder with a Weber conversion on it. I'll definitely have to move the radiator though. I think that's definitely a good suggestion, is to move it out towards the side via like an electric fan or something to kind of push all the heat out. Because right now it's just kind of funneling all the heat and then it gets up onto the driver, which during the winter is not that bad, but during the summer it's pretty bad. During the hotter months. But yep, 4-cylinder Yoda engine. Too small of a gas tank. This is just a garden tractor gas tank. Fuel pump, pressure regulator for the Weber because it's kind of sensitive to the fuel pressure. Battery. No charging system yet so far, because unfortunately the Toyota alternator is kind of a unicorn of a thing to kind of get the regulator set up. So I'll probably just get an internally regulated GM alternator up, modified up in there. Standard 4-speed stock transmission, which is then put up on a chain coupler. I would definitely recommend getting an automatic transmission. It makes things a lot easier when you're off-roading. But anyways, this is just more for gear reduction, this tandem transmission setup. I think if you would have had a automatic transmission, you could probably get by with just one transmission. Yep, chain coupler. This is a Mazda built unit transmission, I think. It's a 5-speed off of a Ford Ranger. Right there you can kind of see the etch line. Rear right, that's just for my own sanity there when I was putting it together. I always fuck up that shit. 5-speed transmission, standard Ford Ranger drive shaft, really shortened up to your Ford 8.8 axle off of a Ford Explorer, which is running disc brakes on each side. You can kind of see the pipe coupler right here, which is just welded up onto the frame to make sure everything's watertight. Kind of see how that's welded in, the differential is just locked in. And there's some room for adaptability. You can see you have some clearance for the pumpkin, so you can put a bigger axle in if you wanted to. This is running a 373 gear reduction right now. You can kind of see the steering lines, the clutch cylinder, throttle, you know, it's kind of ghetto right now. Steering. This is probably the most flimsy thing of the whole thing. The steering cylinders. Yep. Gives you a good hydraulic advantage though, that's for sure. Mechanical and hydraulic advantage. But yep, my main intent here was kind of design and build an economic that someone with, you know, enough brains like a horse like me could put together without a shop and without shop and facilities, just your angle grinder, welder, and give you that universal chassis where you can stick whatever powertrain you want in there, what have you, diesel, automatic transmission, differential steer, you know, utilizing automotive components, stuff that you can get for a decent price if you can find it. But so far I've been pretty satisfied with the machine and what it can do. You know, 3,500 pounds of drawbar pull on topsoil, and it's definitely got its advantages and disadvantages. I would say that. No suspension for one, but it does make it economic. Yep. I hope to eventually put up a cab and a soft top and all that good stuff, but for now I'll leave it as is because I still have that feeling I want to go with an articulated machine, because I've had instances where I'm pulling shit, and when you're trying to turn and you're pulling shit, you can just see the drop off in your drawbar pull. It goes down like 40-50%. It's crazy. But I heard with articulated machines you don't get that, so I might be moving towards that in the future, kind of like a Vitiaz Haglins style setup. But yeah, so far so good. I'm kind of liking the machine, and I'll enjoy it this